Welcome to EduSat Network. Fred, as you know, this week we have a lecture on geography. We have discussed the different aspects of atmosphere, climate, and monsoons. Today we will talk about the climate change with reference to a special reference to India. And for discussion on this very topic, we have in studio very eminent personality, Dr. R.V. Singh. He teaches geography in Delhi School of Economics, and his contribution to geography immense, and that's why he has been selected recently the Vice President of International Geographical Union, and he has been member to various body of climate change and the other in governmental bodies. So I think his knowledge and experience will help us to understand this topic in a new perspective. So on behalf, welcome Dr. Singh for the EduSat lecture on this topic. Welcome, sir.
Thank you, Amrenderji. Dear viewers, today I would like to discuss with you global climate change with particular reference to India. Earlier, we tried our best to understand climatic condition, atmospheric structure, then the variety of uncertainty in the atmospheric phenomena. Then we tried to understand the monsoon, different theories of monsoon. It is very important to see the aspects, various aspects of global climate change in Indian situation. In this context, I would like to elaborate the trends in the global climate, taking into consideration of the sea level rise, temperature, then precipitation aspects, how we can understand this process, this physical evidences, what are the processes involved in this, and then I would like to take the impact, and then I would like to put before you 3 case study from India, one taking from the mountain, and then one from the arid environment, another from the semi-arid environment. Climate change is a significant change in the statistical distribution of weather pattern over periods ranging from decade to millions of years. It may be change in a average weather condition or the distribution of events like a precipitation or temperature, or more or fewer extreme weather events. The term sometimes is used to refer specifically the global climate change caused by human activity, or sometime in other words it is also called the anthropogenic climate change, as opposed to changes in climate that may have resulted as a part of Earth's natural processes. Climate change is not a new phenomenon, it is now reality. On the basis of the several signs and signals we are getting, I can tell that we have substantial evidences to prove that climate is changing, and even our Indian situation. And the climate of Earth swings in between the glaciation and deglaciation. This all historical perspective you know and you might be remembering. The concern at present is the high rate of change and the causal factor, and largely these causal factors are anthropogenic in origin. That is the more important part to understand. I would like to put before you first the trends in the global climate change. If you will see this, the 2001 IPCC report, Intergovernmental Panel on Climate Change, you can find this surface temperature could rise by 1.4 degrees centigrade to 5.8 degrees centigrade. Then increase in the global temperature in 20th century was observed at 0.6 degree plus minus as per the IPCC. Then recently we also got some evidences and very substantial data about this, the change in 0.46 degree centigrade. So this has started affecting the glaciers all over the world. Globally, I would like to put before you, climatically speaking, 1990 were the hottest decade and 1998 was the hottest year since 1861. Moreover, 7 hottest years since 1861 all fell in the 1990s. During 20th century, sea level rise also rose by 10 centimeter to 20 centimeter. Now, how we can understand these physical evidences of climate change? For that, we have several methods. Temperature analysis, temperature measurement we can do, historical and archaeological evidences, variety of factors we can incorporate, glaciers and arctics, sea ice loss and the ice cores can be examined, vegetation, vegetation, even the old historical times and the vegetation in the, lake sediments or the various, analysis, pollen analysis, then the sea level change also is one of the important indicator. So, these are the some of the important processes can be examined for understanding the physical dimension of the climate change. Now, I would like to put before you here the COT, that is the very important aspects of understanding the climate change, and the 3 diagram in here you can see the carbon dioxide, then the methane and nitrous oxide, and you can find in all 3 we have a tremendous in the post industrial development era, tremendous change in the pattern. And if you can see this, the largely human activity have increased the after the 1750, and that has been a very important factor for increasing the major greenhouse concentration. Since more specifically I would like to tell you this, the 1950 average global temperature has increased 0.8 degrees centigrade since 1900. Warming since the 1950 very likely more than 90% chance due to the human increases in the greenhouse gases. If you will see here, this I would like to put before you and classify the different period through this diagram coming from the IPCC 2007. And if you will see this, the global mean temperature, I would like to here divide, and you can understand from your own perception the type of problem we are getting. Now, you can see this, the in last 25 years if you will see, we have the changes of 0.44 degree centigrade, but if you will go to the 150 years, then we have changes of 0.68 degree centigrades. So, continuously we have the change in the global mean temperature you can observe through this diagram. Here you can see this one is at average of 1961 to 1990, and is taken the average, and then in relation to average, I think this the data of coming from the IPCC 2007 starting from the 1860. Now, you can see until 1980 even you can find the minus in this the whole degree centigrade. If you see this difference in the temperature, but after that, after 1980 we can have a very rapid increase, and this rapid increase coming from the variety of measurement and variety of the monitoring system, as you can observe from this diagram. Similar way, if you will see this normalized annual mean temperature change, for greenhouse warming experiment, you can see here the this data coming from the UNFCCC, United Nations Framework of Convention of Climate Change, and now you can see in northern hemisphere that most of the temperature change we have in the northern hemisphere. So, northern pole and northern side we have the more greenhouse warming in the world. Similarly, here through this diagram you can see this the temperature anomaly of the June 2011, with respect again for the 1961 to 1990, taking this base period, and you can find here that this the whole North America, Europe and the Asia, largely these are also the region considered is a very highly densely region of the world, and one can see a very positive relationship between the density of population, anthropogenic activity and then the temperature. Globally, if you can see that average land surface temperature for June to August 2012 was all time warmest. June August on record at 1.03 degree centigrade, above the average, that is the most recent data one can get, and this shows a very great signal that climate is changing. Similarly, now you can see this the global annual land precipitation anomaly, continuous starting from the 1900 to 2000, you can see the tremendous variability. So, the climate change, I would like to use the word the climate variability is the most appropriate and significant word also in the context of the South Asia, rather than calling the climate change, because we have a very clear cut variability coming from the temperature and the rainfall data. Now, you can see here particularly the Arctic sea ice fluctuation. Through this very important, starting from the 1980, and if you will come to the 2010, you can see this how this ice fluctuates, this decreasing. So, this shows that between the 1980, 85, 1990, then you can see this 95, 2000, 2005 and then the 2010, we have the various differentiated fluctuation. Now, I would like to bring before you, apart from anthropogenic factor, I would like to bring before you some of the natural factors. These are also very influencing the global climate change and the variability. Changes in the sun orbit, that is also, and this also relates to the changes in the solar output, continental drift, mountain building process, volcanism, geomagnetism. But one can say that it is largely the product of anthropogenic origin or anthropogenic causes. 4%, I would like to put before you some of the important statistics. 4% of the carbon emission come from the industrial processes, 7% come from the agriculture. For example, the methane emission from livestock and the manure, and nitrous oxide emission from the chemical fertilizers. Then 21% carbon emission coming from the transport, 65% come from the usage of fuel for the generate the energy, excluding the transport, and about 40% of the carbon emission are the result of the by the individual, like a deforestation, energy used in the home, driving a car, air travel. These are some of the important anthropogenic activity of individual influencing the global climatic pattern. And so, that is why you can see here, if you will see this, the atmospheric chemistry changes at Mauna Loa, particularly the carbon dioxide pattern. Here you can see the 1955 to the almost the 2005, the continuous rapid, the increase. It's a very rapid increase of the CO2. Looking the more closer view, very recent, mean CO2 and Mauna Loa. Now you can see 2008, 9, 10, 11 and 12, continuous increase, very rapid in the parts per million, starting from the 385 to almost going to very touching almost 390 parts per million. Now, you can I would like to put before you here what are the important sources of the greenhouse gases. For water vapor, you can see largely the sources coming from ocean, river, plants, soil. Then CO2, largely the combustion of fossil fuel, respiration, methane, particularly the CH4 coming from the wetlands, ocean, combustion, animals rearing. Now, for the United States, I would like to put before you this the sources of anthropogenic greenhouse gases coming from the different sources. And now you can see here that the carbon dioxide from the fossil fuel 81%, if you will see the by gas wise, then nitrous oxide 4%, methane 8%, other gases 5%. Then if you will see the sector wise, now you can see the transportation 28%, electricity generation 34%, industry 20%, then followed by agriculture 7%, building 6%, and then building commercial, and then building residential it is 5%. So, ultimately here the electric generation, transportation, industry, these are the important. Even agriculture is not a very important source in the United States. And so, we have the effects on the snow and ice that can be observed very clearly all over the world. Now, you can see here this the Arctic sea ice extent, how you can see the average of 1979 to 2000 and how it declined in 2007 and 8. Then mass balance, particularly the cumulative mass balance of the various glaciers in a different mountain system. Now, you can see here these are the some of the mountain system, and the all starting from 1960 to the 2000, you can find the except the one, I think the almost the every after 1990 everywhere you can find the decline of the mass balance, but in 1-2 cases until 1990 maybe almost the equal. And so, we have the effect on the precipitation, particularly the lot of changes, because due to the warming we have the more water vapor, and due to the water vapor there is a more probability of precipitation, but it varies from region to region, area to area, and this is a very important aspects too. Now, you can see here how the effect on precipitation in the United States, it is a more looking this the more than increase is the more than a standard deviation, if you see the more than 0.75 in the US, Europe, and also the part of India and the some part of the Africa, where we have the high concentration of population density and also the anthropogenic activity. Similarly, you can see this estimate of the 20th century sea level rise and increasing starting from the 1860 to almost the 2000, almost the increasing. And same way here you can see that that several climate models, I would like to just see that how it is moving. Different they predict that the due to the natural factor, only if suppose if natural factor is there. So, blue one very clear cut here you can see that if only the natural factors are responsible, then we have the very little greenhouse gases. But after the adding natural, volcanic and solar, and then the greenhouse gases, different sulfates or ozone related issue, then you can see that how that this temperature in degree centigrade, how it is moving. So, I would like to put before you this largely the impact of climate change. Glacier melt in the Himalaya is projected to increase flooding, rock avalanches from destabilized slopes, and to affect water resources within the next 2 or 3 decades. This will be followed by decreased river flow as the glacier recede. So, one can see also the simultaneously short term more flooding problem, but in long term we have the more drought problem also exist in this region. Fresh water availability in Central, South, East and Southeast Asia, particularly in the large river basin, is projected to decrease, could adversely affect more than 1 billion people by 2050. So, this is a one very important. Then endemic morbidity and mortality due to the diarrheal disease primarily associated with the floods and droughts are expected to rise in the East, South and Southeast Asia. Then increases in the coastal water temperature could also exacerbate the abundance and also the toxicity of the cholera in South Asia. Now, I would like to put before you, taking we might have seen this the how temperature, precipitation and then impact on the sea level, impact on the ice and glaciers happening or happened all over the world. Now, I would like to put before you the situation of India. Now, you can see here this the temperature and rainfall data. Large scale variability you can find starting from the 1750 to almost the 1975, large scale variability in the temperature. A smooth line indicate the low frequency variation, but you can see here that the more large scale variability in the several years one can see. Similarly, if I would like to take to the 1908 to 2003, the variation of all India mean, maximum and minimum, all three measurement here I would like to put, and now you can see through this diagram a clear cut trend, also by the Kotwale and the Kumar, they observe this the clear cut and the by statistically analyzing this the mean temperature, maximum temperature and minimum temperature, one can see this the clear cut variability in all three parameters. And so, climate change brings several impact in India or Indian situation. Variable rainfall pattern, that is the most important thing I would like to summarize here. The variable rainfall patterns, melting of glaciers all over the world. You might have seen the Arctic and particularly northern hemisphere, this and various places, the decreasing the mass balance of the glaciers. On the other hand, we have due to the deforestation, rainfall pattern has also increased, and then we have the increased runoff because of the massive deforestation due to the various anthropogenic activity, particularly in the developing country, tropical Asia, tropical Africa and tropical America. And this brings before us excessive flood and situation. In the short term or maybe in the high flow season, monsoon, this we in India we have a very typical monsoon, and so that is why excessive flooding in the high flow season. On the other hand, we have the water scarcity. For long term, if you will see, we have the water scarcity problem for long term on or the off season or the low flow season, I can say low flow season, non monsoon time. And then what will happen? Water is a very important resource for agricultural development, and then we also found the decreased agricultural productivity due to this process. Then subsequently, we will also have the impact on flora, fauna and also the human beings. Now I would like to take up a case study of mountain environment. More than 5,000 to 8,000 glaciers exist in the Himalayan region. Now you can see this, the Himalaya, and then we have simultaneously Nanda Devi Biosphere Reserve. This all biodiversity, such biodiversity region, depends on the existence of the glaciers. And due to the global warming, if glaciers are melting, we have within the mountain system also the very large scale impact, on whatever the 10 to 12% agricultural land we have. Then, but we have the biodiversity, including the medicinal plants. Then we have the lot of different species, animal species and all. If we have the any impact on agriculture, impact on the, then we also will have the impact on the human being, directly. Then second impact I would like to put before you, here you can see this, the eutrophication of the famous Dal Lake in Kashmir. People are collecting the weed. You can see this, the very beautiful Dal Lakes. Many places, even due to the sedimentation process, because we have the more chemicals and variety of nutrients also coming to the water, causing the total water degradation in the region. And even many natural springs are drying up, So this one is a both combination of cumulative effects of the global warming and then also the deforestation and various other factors. Retreating the Gangotri glaciers, various evidences one can see that Gangotri glacier, and particularly in the central Himalaya, one can see the melting of glaciers, and this region also is a very, very important, particularly for sustainability in the Ganga valley. So this the whole Indus, Ganga and Brahmaputra valley largely facing a severe challenges due to the instability in the Himalayan glaciers, or the in more specifically the Himalayan glacier, but also the large scale deforestation in the Himalaya. I would like to put before you here a case study. You can see here the Milan glacier, Tipra glacier, Donagiri glacier, these three small glaciers. We tried to see the Oster data through here, all three you can find the Oster satellite data, and then the old data we have taken into consideration from the Survey of India topo sheet. Now you can see here that the green part is the area all covered earlier by the glaciated area through the snow cover, but in all three you can find that how the glaciers marked by the Survey of India topo sheet and glaciers marked by the Oster image, we have the decreased area. So this shows that retreating nature of snouts of Milan, Donagiri and the Tipra glaciers, the three very important glaciers in the Nanda Devi Biosphere Reserve area. And so what will happen? We have impact all red area you can see, the Indus system, Ganga system, Brahmaputra system. Flooding is an annual phenomena everywhere. This year you might have seen and you might have heard devastating impact of flood particularly in the northeastern region. So these flood prone areas not only are in the Indus system, Ganga system, Brahmaputra, all three, but I would like to emphasize here this all system largely getting the enormous pressure from the Himalayan uncertainty, Himalayan anomaly or the Himalayan degradation in the form of deforestation, glacier melting, the high rainfall, and so deforestation. 70% of the land belongs to the community. People are going for more and more grazing, and so we have changes in the land quality, changes in the land degradation. One can see the tremendous land degradation in the form of landslides, rock falls, land subsidence, soil erosion. These are the processes, and then debris are coming to the water bodies, and these the water bodies, even the big rivers and the small water bodies, they are getting a very substantial sediment load, and they are drying up, and then flood frequency is increasing. So, Indus Ganga Brahmaputra river basin under the crisis. I would like to elaborate here, even quoting from the IPCC 2007. Glacier melt in the Himalaya is projected to increase flooding and avalanches from the destabilized slope and to affect water resources within next 2 or 3 decades. This will be followed by decreased river flow as the glacier recede. It is projected that crop yield could decrease up to 30% in South Asia by the mid 21st century, according to the Intergovernmental Panel on Climate Change. Now, here you can see through this that one can see the combination of the what is happening at the Himalayan scale, deforestation, melting of glaciers. Now, you see this few years back, the Kosi river, the normal course of the Kosi, and then you can see the darker one, the totally course changes due to the small break in the dike in one place. The total, one can see a total change of the Kosi river bed causing large scale deforestation in Bihar few years back. So, here you can see the snow melt, deforestation, high runoff is one aspect, and then the defects and the break in the dike is another localized factor that accelerate the process of the changing the river course of Kosi, causing large scale devastation in the Bihar state. Then you can see in the northeastern part in this Assam, how people are living in these flood prone areas. You can see this the biodiversity in the Kaziranga National Park is very famous for one horn rhino. Now, you can see the elephant, one horn rhino, how threatened biodiversity by the flooding. So, the climate change impact not only not bringing on agriculture, not bringing directly to the human being, but you can see that how biodiversity is very severely threatened by the flooding in the famous Kaziranga Biosphere Reserve. Then what we can do? It is very important to utilize the data, remote sensing, geographic information system. Now you can see here the one map prepared for the Ram Ganga basin, looking the river bed, then demarcating the flood affected area, then we try to identify the flood affected villages, flood affected people, flood affected area. Such type of the map is a very important for the policy maker and the decision makers, particularly when they have to start the relief and the flood prevention measures. Then also we are trying to do the mapping of geohazards, along the river Spiti and the Satluj. Here you can see, because this region also is facing the impending global glacier lake outburst flood. A few years back we have the Parachu this Globe accident causing a lot of devastation in the Himachal Pradesh. So, the geohazard mapping, taking into consideration of the various hazards, their occurrences, historical evidences, and then preparing the map. Such maps are very, very important for implementing variety of policy measures in this zone. Then also here we try to vulnerability assessment in the mountain. This map is a combination of 4 maps, 4 type of disaster. First we have done individual risk assessment for the landslides, flooding, then the earthquake vulnerability and the cloudburst, and then we combine together, and now you can find through using this the multi-criteria analysis in the GIS framework, Geographic Information System. You can see here we can identify the area very high, high, moderately high, low or very low. Very high means it is very prone to many disasters like earthquake. This region also seismic zone. So, earthquake, landslides, the flooding also is some phenomena, localized phenomena in there, but very low means less probability of this. So, such maps are very, very important, particularly for relief operation, for implementing disaster prevention measures, and also the capacity building in the region. So, this one is a in the Uttarkasi area of the Uttarakhand. Then I would like to take the case study of the arid environment. We have the 12 district west of Halauri, very, very arid, large dislocate sandy tract of land without any surface water and vegetation, very. You can find the massive anthropogenic activity. Then here you can see this rise in temperature. Apart from the rise in temperature, taking a very short term data, but if you will analyze the long term data, you can find the more better picture. But even analyzing the short term average temperature in degree centigrade, you can find a very clear cut climatic variability is visible here. Then we applied also to Thornthwaite climatic classification here, and now you can see here that how much area, you can see that a very substantial part of area has been converted into the semi-arid to arid situation. Then also a small part of the dry subhumid area has been converted into the semi-arid situation. So, we have continuous changing of this type of dry subhumid to semi-arid, and then the semi-arid to the arid situation. This shows that also we are getting physical evidences of climate change in the not only in the Himalaya through the glaciers, but also in the arid region. Then we tried to prepare the vulnerability map also for the, here we have taken the vegetation, water availability, population density, literacy, variety of biophysical and the socio-economic indicators we have combined together in order to prepare the vulnerability map and here you can find that the western part of Great Indian Desert consisting of Jaisalmer district came into the high vulnerability, where we have a very high temperature, less vegetation, low water availability, low fodder availability, also the very little livelihood security available in that area. Now, you can see I would like to put before you another case study of semi-arid environment, and now you can see this also here: climatic variability, average temperature rise in August for 1948 to 2008. Then we have taken variety of indicators here, you can see. Now, similarly, we have done also for the arid environment. This is for a semi-arid environment of Haryana state, where we have considered population density, forest cover, water resources, area under irrigation, then off farm, other type of rate of food production, level of literacy, per capita income, then variety of income sources, land holding size, level of land degradation, population growth, groundwater, and then the poverty. Combining all together, we are able to prepare the vulnerability map also for the semi-arid region. Such type of the maps are very, very important, particularly for the policy makers, and this is the very important contribution academic community can give to the policy making institution and policy making body by using the emerging areas of science like remote sensing and GIS. We can prepare such type of the map. Such map can give a very important for prioritizing the problem. You can see here that sprinkler irrigation methods, this then Indira Gandhi lift irrigation scheme also in that area, because the water is a very important resource for the semi-arid environment, and for rational use of water you can find even farmers are using the sprinklers methods. Now, I would like to put before you the global initiative to mitigate the climate change, and for that we have the WMO, World Meteorological Organization. Under WMO we have the WCRP, World Climatic Change Research Program, World Climatic Change Research, and IPCC is a very important part of the WCRP, World Climatic Change Research Program. The Intergovernmental Panel on Climate Change, the group that produces the main reports on climate change. It is a scientific intergovernmental body set up by the World Meteorological Organization and by the United Nations Environment Program in 1988. The IPCC process involves hundreds of scientists from about 140 countries, a variety of fields and range of views. Main function of IPCC is to assess the latest peer reviewed literature in the area of the climate change. They used to see the scenarios, various literature, various the experimental work, compare different computer model results, and then to achieve consensus about where the weight of the evidence points and where uncertainty lie. Then I would like to take up the United Nations Framework Convention on Climate Change, UNFCCC. It is also an international environmental treaty negotiated at the United Nations Conference on Environment and Development, very popularly known as the Earth Summit at Rio de Janeiro in 1992. That was a very important initiative taken by the global community after the submission of the report on the World Commission on Environment and Development. The objective of the treaty is to stabilize greenhouse gas concentration in the atmosphere at a level that would prevent dangerous anthropogenic interference with the climate system. The treaty itself set no binding limits on greenhouse gas emission for individual countries and contains no enforcement mechanisms. The parties to the convention have met annually from 1995 in conferences of the parties, it is very popularly known as COP, to assess progress in dealing with the climate change. In 1997, the Kyoto Protocol was concluded and established legally binding obligation for developed countries to reduce their greenhouse gas emissions. Then the third important aspects I would like to tell you that Kyoto Protocol, that was a very important step taken by the global community at city Kyoto in Japan. It is also a part of the UNFCCC that set binding obligation on the industrialized country to reduce their emission of greenhouse gases. So, this was a very clear cut first initiative taken for reduction of the emission of the greenhouse gases. Under Kyoto Protocol, 37 industrialized countries and the European Community, Annex 1 party, very popularly known as, commit themselves to limit or reduce their emission of 4 greenhouse gases and 2 groups of gases, hydrofluorocarbons and then perfluorocarbons. At negotiations, Annex 1 country collectively agreed to reduce their greenhouse gases emission by 5.2% on average for the period 2008 and 12. This reduction is relative to their annual emission in a base year, that was the 1990. Then I would like to put before you this 8-point very important program in India, national initiative, what it is popularly known as the National Action Plan on Climate Change. This includes National Solar Mission, that is a very important. India is blessed by a vast sun light and the solar resources, solar energy, followed by National Mission on Enhanced Energy Efficiency. Apart from the energy, non-conventional energy sources like solar and wind, we have also to improve our energy efficiency. Then sustainable habitat in the form of like a green neighborhoods or the green buildings initiatives. Then the National Water Mission, take into consideration of the water harvesting initiative. Then National Mission for the Sustainable Agriculture. Then strategic knowledge for the climate change, and then particularly the Himalaya, we have discussed here as a case study of Himalaya. So, that one is another important mission. Now, what we can do here? Now, through this diagram you can see that what will happen if we will not reduce the carbon emission, but by avoiding the doubling of the CO2, because it is continuously increasing, then we can achieve this one. So now you have to decide what we can do, whether we want the tripling or 4 times increase of CO2 and then causing problem to our human sustainability, but or they avoid the doubling and then we will have the more in in the direction we move towards sustainable development. Most important point I would like to summarize here, like produce more fuel efficient vehicles, reduce vehicle use, that is itself very important, improve energy efficiency in buildings, develop carbon captures and storage processes, increase solar power and micro hydropower, more specifically increase afforestation, plant vegetation and improve the soil carbon management strategy. Now you can see here that the how enhancement of adaptive capacity by using the non-conventional energy sources. Suljan wind turbine in Jaisalmer, even interior area you can find that how people are using the, we need to use the such type of the non-conventional energy sources in our whole energy use in India in order to mitigate the climate change. I would like to conclude by using this deep future, the one statement of Kurt Steger, that by succeeding so spectacularly, crowding into every imaginable habitat and weaving ever more complex social and economic network, our species is now pressed so tightly against the physical limitation of life on a finite planet that almost any kind of environmental disturbances is potentially very destructive, unquote. Then I would like to stop here. Thank you.
So, how you see the in coming years the social climate change will have impact on the life of social people, and this suggestion you suggested, if it incorporated, how much time will take to overcome such problem what we are facing now?
You know, it is very important. We have the 3-4 important gases as we have seen. CO2, that is important, methane, and then and largely the energy generation, then the agriculture, then deforestation. These are the important activity. We have to regulate our activity, very important. And I think within 10 years already we are getting the sign and signals. Now in case of Delhi, I can tell you that due to the several measures already we have little bit decrease of the pollution level and the warming, and we have such type of sign and signals in several part of the world also.
So comparative to that, if we take effective measures, then we can control such kind of
effective things. And this should become the mass movement.
But one things which
actually the mass movement.
Yeah.
Everybody, we have to participate in this whole, like we public transport system. We can individually, several things individually we can avoid. Deforestation, we can avoid. Fuel type of fuel we use, we can avoid. Energy, we can. So that our travel behavior. So we can regulate ourselves. The type of energy efficient bulb and tube lights and all. We have to use, and wherever we have possibility, afforestation.
And one major thing what we noticed that in the rural area and urbanization more becoming a part of the life in the rural area. So how do you think that this will create, this will give a shift to the current socio-economic, environmental, balance? How will get shift coming is?
In the rural region.
Yeah.
It's a lot of initiative taken at rural level. And I would like to tell you this, the Panchayati Raj. If we can strengthen, streamline the Panchayati Raj institution, and our Panchayat leaders can become very active, the initiator of the environmental movement within their Panchayat, I think
that will give impetus.
Yes, we have lot of the wasteland. How we can use the water harvesting, the ponds, this water harvesting structure can be created, so we can have the rainwater, we can store and we can use during the drought time. So, variety of things. It is very important for the government and the policymakers to prepare the manual for the how they can operate, you know.
As a expert of the climate, and have you noticed any kind of a study done by because we have a tradition of storing water, tradition of environment friendly activities. There are various kind of activities being done across the country, and that have been very helpful long years.
Yes.
But introduction of certain new things like pipeline and all that, even we consider the Rajasthan areas, those traditional things have been now losing their grounds and modern things being adopted. So how this practice having impact on life and also on the environment, and what could be the best alternative of this?
We have several initiative, good initiative all over the country. You can say starting, I would like to start with how the Chipko movement, in the interior Nanda
Garhwal,
Devi
yeah.
yes, Nanda Devi Biosphere Reserves in a rainy village, how the Gaura Devi, late Gaura Devi started this movement, and then our Chandi Prasad Bhatt and Sundarlal Bahuguna and several people,
Others join
but what is the impact? You can see, go to now in Uttarakhand and Himachal Pradesh, every village you can find the Mahila Mandal, some organization.
right.
So it is a very good sign and signals. The Mahila member Mandal exists, and they are taking up the lot of responsibility for checking the tree felling, the afforestation program, the illegal cutting, all this. They are taking up responsibility. You might have already knowing the this Johats scheme, Alwar district.
Yeah.
Sukhmajiri experience in. So what we have some isolated stories.
Yeah, but
What we need that
concerted effort.
This should also become the mass movement in our country.
Okay. So, well, friends, as you come to know about the steps are being taken on individual level, and that have also yielded impact and positive result we have found. But what we need to do is to make a concerted effort to save the environment, and onus is on all of us, not only on the government, or you can shift the onus to anybody else. But when we take a concerted effort, certainly we'll have a better result. So with this word, we conclude the lecture. I thank all of you for watching lecture, and on behalf, I thank Professor R.V. Singh for giving such an insightful lecture. Thank you very much.
Thank you. Thank you.